So lots of people expect that these two are the same. So lots of people think sine -1 is the same as 1 over sine x. But they're not. So that's what we're looking at today. So another way to write sine to the -1 is arc sine. So if you see this, it starts and stops at a point. So it doesn't keep going. And it's not the normal round like that from a sine graph. It's going like that, which kind of looks more like a tan graph. So what is the domain and range of this? Because this is the most important part of today's lesson. What's the domain and range of this? You discovered was -1, 1, and the range is -pi over 2 and pi over 2. So today we're looking at solving some questions involving these arc trig functions. So it's really important that you consider these two, because if they're outside of those, there is no solution of -1, 1, and this time a range of 0 and pi. Okay, so arc cos, this is the same as arc cos. And that's the domain and range for arc cos. The domain, it goes from -infinity to infinity, and the range, oh, it's the same as sine. There you go. So if you look at the first one, sine to the -1, so first step to solving is to let x equal to the function. Okay. Then we can bring the sine over. So now we have sine x is equal to 2. We then can, but we then look at this, right? So imagine this is equal to y. We now have a y value of 2. Now if you look back at the domain, that's outside of it. So 2 is not an element of -1 and 1. Therefore, there is no solution. Okay. So let x equal to sine -1 square root 3 over 2. Sine x equals square root 3 over 2. Now, grade 10 and 11, if you have sine x equal to something, you can use the special triangles. So square root 3, 2, 1, pi over 3. So opposite over hypotenuse, so x equals pi over 3. Pi over 3 is an element of -pi over 2 and pi over 2, so it's between these two. So therefore x equals pi over 3. So there is a solution. Or you can write the solution is x equals pi over 2. Okay, hopefully that one makes sense. Let me double check the first one. I think I made a mistake possibly. So we're looking at sine x equals y, right? So this is the domain and range for negative sine x. We're looking here at sine x. So the sine x still has to be, so the domain and range swap for sine x. Does that make sense? So this is the domain and range for sine negative x. When we're looking at sine x, the domain and range swap.